Chapter 1.10.9 Scheduler Performance Tuning. Summary. The Kubernetes Kube Scheduler is responsible for placing pods on nodes, choosing ones that meet specific requirements. This involves finding feasible nodes and scoring them to select the best option, a process known as binding. To optimize performance in large clusters, you can adjust the percentage of nodes to score setting. This determines how many nodes the scheduler considers during the scoring phase, balancing speed and accuracy in pod placement. Nodes are scored in a round-robin style, considering zonal distribution. For clusters under 100 nodes, adjusting this setting won't significantly impact performance, but in larger clusters, a thoughtful approach ensures effective pod placement. Scheduler Performance Tuning. This code snippet is using the kubectl command to get information about pods in the kube system namespace and then filtering the output using grep to only show the pods related to kube scheduler. It is a common command used to check the status and details of the kube scheduler pods in a Kubernetes cluster. Kubernetes version 1.14 introduced kube scheduler as the default scheduler, which places pods on suitable nodes in a cluster. Nodes meeting pod requirements are feasible nodes. The scheduler picks the node with the highest score for running the pod. The scheduler communicates its decision to the API server via a process called binding. For large clusters, performance tuning optimizations balance quick scheduling and accurate placements by adjusting the kube scheduler. The percentage of nodes to score setting in kube scheduler configuration determines node scheduling threshold. Change the threshold by editing /etc/kubernetes/config/cube-scheduler.yaml and restarting the scheduler to ensure it's configured correctly. Node scoring threshold. The kube scheduler improves scheduling by limiting node searches once enough feasible nodes are found. This is helpful in large clusters, saving time over the naive method of examining every node. Users set a threshold percentage of nodes. The scheduler converts this into a number, stopping when this is exceeded to score nodes. By default, Kubernetes uses a formula to set the threshold, ensuring at least 5% of nodes are always scored. For complete scoring, set the threshold to 100%. To enhance the kube scheduler's efficiency, it limits node searches after identifying sufficient feasible nodes, thus reducing time consumption in large clusters. Users can define a percentage for feasible nodes, which gets converted into an integer. The process of node iteration during scheduling is detailed elsewhere. A default threshold applies if unspecified, ensuring at least a 5% score of nodes. Complete node scoring requires setting a percentage of nodes to score to 100. The kube scheduler optimizes by halting searches when enough feasible nodes are found, saving time in large clusters. Users specify a percentage, which is transformed into an integer limit. During scheduling, once this is met, the process moves to node scoring, leaving node iteration details elsewhere. Default thresholds ensure no fewer than 5% of nodes are scored, but users can demand full scoring by setting it to 100. Kube scheduler enhances scheduling by halting node hunts on identifying a sufficient number of feasible nodes, saving time in expansive clusters. A user-specified percentage sets a boundary, guiding the scheduler. Default calculations apply if not set, scoring no less than 5% of the total nodes. However, complete node scoring can be achieved by setting the percentage to 100. Further details of node iteration appear elsewhere. Improve kube scheduler efficiency by stopping node checks once enough feasible nodes are found, optimizing it for large clusters. Set a percentage. This translates into a number for node checks. Default mechanisms ensure 5% or more nodes are evaluated, with a lower threshold of 5% in place. For 100% node scoring, users should adjust the threshold accordingly. Node iteration is elaborated in related documentation. Example. The provided YAML code sets the percentage of nodes to score parameter in the Cube Scheduler configuration object to a value of 50%. This parameter determines the threshold for scheduling nodes in the cluster, balancing scheduling outcomes between latency and accuracy. This configuration setting helps optimize the performance of the Cube Scheduler in large Kubernetes clusters. An example configuration sets the percentage of nodes to score to 50%. Tuning percentage of nodes to score. 1. The percentage of nodes to score setting must range between 1 to 100, influenced by cluster size. 2. Clusters with fewer than 100 nodes default to checking all nodes, rendering low values ineffective. 3. In small clusters, default settings are advised, as minimal changes won't improve scheduler performance. 4. Lower percentages mean not all nodes are scored, possibly resulting in suboptimal pod placement. 5. Avoid settings below 10% to prevent poor scheduling unless score is inconsequential and throughput is key. How the scheduler iterates over nodes. The code segment represents two zones, each with a list of nodes. The scheduler iterates over nodes in each zone to find feasible nodes for placing a pod. The scheduler then scores the feasible nodes and selects the node with the highest score to run the pod. The code represents the order in which the scheduler iterates over nodes in two zones. The scheduler first iterates over all nodes in Zone 1, Node 1, Node 2, Node 3, Node 4, before moving on to Zone 2, Node 5, Node 6. The nodes within each zone are iterated over in the order they are listed. This section is for those interested in how a feature works internally. It explains the round-robin method the scheduler uses to assess nodes in a cluster, ensuring fair chances for all nodes to run pods. The scheduler evaluates node feasibility by starting at the beginning of an array of nodes, stopping upon enough nodes being scored based on a preset percentage. It resumes from its stopping point for the next pod. In cases where nodes are across various zones, the scheduler ensures consideration of nodes from all zones. For instance, with 6 nodes in 2 zones, the scheduler evaluates them in sequence, cycling back to the start once all have been checked.